When we're kind of going back here, what I'm going to try to do as we go piece to piece is at least label what it is that we're looking at so we can know where to look if we need to. So graph the lines, find the point of intersection. So this is back in 6-1 here. So I've either got to remember, using my noggin, how to graph this, or I have an option. I could use the calculator. So I'm going to kind of give you options here. We'll see how this goes. So if I'm just doing my regular graphing, my number on the end is my y-intercept. So this first number tells me where that first dot's going to go. The number in front of my x is my slope, my rise over run. So here, since my slope is 3/1, this is why we get in the review, to kind of rustle up some of them old memories here. So we're going to go up and we're going to go right. So 1, 2, 3, 1. 1, 2, 3, 1. And if you run out of room, we can just do the opposite of both of these. So we can go down 3 and left 1. All my dots are lining up here. And I get that set. And I'm going to do the exact same thing with the second one, and then I will show you how you can do this in the calculator as well if this ain't clicking. My y-intercepted before. -1. Yep. This time I'm starting at 4. There is a negative in front of that 2. You always start at the y-intercept. So this said -1, so I started at -1 for y, and then I went. On this pink one, since the y-intercept is +4, I'm going to start at 4. But this time my slope is -2/1. So I'm going to go down 2 and right 1. Down 2 and right. And what I'm shooting for here and hoping is that as I do all these dots, I'm going to see a common dot somewhere. And if I do, that is my solution. Now, I can't just circle it. It's a coordinate point. So we always do x first and then y. So to get lined up with that point, I went right 1 to where x is 1. And I went up 2 to where y is 2. So here's the thing. If graphing is not your expertise, you can go into y equals. You can type in the expression and then just pull up the chart and check this out. There's 0, -1. There's 1, -4. There's 1, 2. There's 2, 5. I can just plot the points that I can get in here and graph them. And then I just do the same thing with -2x + 4. Second graph gets me to the table. So if I don't remember that part, I might want to put that in somewhere. But I look again and I'm like, okay, so 0, 4, 1, 2, 2, 0, 3, -2, 4, -4. And I'll let the calculator do all my pointing for me, and then I just got to figure out where it's going. So it's kind of your call. And if I get to a point where you're like, Hardy, I know this stuff. I don't need to be... Fire away. Go to other parts. Speed ahead, because there's going to be a video up of this anyway. So, just saying. Okay, solve using the substitution method. Oh, let's see here. This is still a Unit 6 thing, isn't it? We're going to kind of notice something here. Is there going to be a pattern? Is this going to go in order? Maybe. So I look and I go, okay. When both equations are y equals, well, they're not, Hardy, so what the heck? Oh, Only one equation is y equals. Okay. Take the expression in y equals and replace it in the second equation. In other words, take x plus 2 and stick it in there for y. So step 1, I'm going to start copying this second expression until I get to y. So it's that exact same equation, except I've taken out the y and replaced it with this. Now it's only x's. So we're going to solve the equation for x. So I got to do some distributing. Here's the part I've got to watch out for. This could mess me up for the whole thing. These x's are on the same side of the equals. With those being there, do not do opposites to them. Just put them together. Negative 4 plus 3 is negative 1x. And I get that. I didn't eliminate it, I just substituted its value into the other equation. And now we're just doing some two-step equation business here. Dividing by negative 1. Now, that tells me the x value. I'm not done. Step 3. Substitute the value from this step, substitute the x equals 3, into the y equals equation, and solve for y. So now it's just, y equals x, which is 3, plus 2. I just figured that out. And I've got my solution. So again, step by step, right there with some examples to the side, that sounds like a decent deal to me. So again, you can either use the notes that are free, or you can use the review itself, but it's basically almost costing you 2 letter grades. No, 2 letter grades. A C would be the highest score if you use the review. Just saying. Now, is there still value in doing the stuff on the review, though? Yes, because you're seeing all this stuff, you're doing it, and then when you go to do it later, it's going to make it easier. I'm just saying. So yes, underneath there are the notes, except for Unit 6. Unit 6 is going to be here tomorrow because someone forgot to copy it. I will have those there tomorrow. I'll keep you all up to date with me, one way or another. Solve by elimination. You're like, Hardy, they are just in order, aren't they? Yeah, they are. Okay, no more mystery to that. So what's my job here? I'm hoping that I can just add down and make a variable go away. That's what I'm hoping. It may not happen every time, though. So here I go, and I'm like, negative 3 plus 5. Okay, that's 2. That didn't cancel out. Negative 6 plus 6, though. Ooh, that does. That's good. And negative 9 plus negative 5 is negative 14. Hey, I only got one step I got to do. This is nice. So here... So I got my x already. That was cool. But I'm not done. Now I got to go back to either one of my first 2 equations. I like positive stuff. So I'm going to do the second one here. And this time, again, I know what x is. It's negative 7, so I must substitute that in. Everything else... Yes. Yes. Any notes are all good. And if you've misplaced any, I've got blank copies on the back table. But yeah, otherwise, if you got them, you can use them. You can use them. And so we're just going to work through here. Ooh. I know, I'm looking at this myself and going, what the? We're going to get a decimal? Is this possible? Oh my gosh. Oh my gosh. Oh my gosh. Okay, let's try that again. I got to learn to multiply. 5 times -7 is not -12. Not -12. It happens. It does. We all have our times. That's better. Good recovery. Good recovery.
Okay, but for the next one, don't you either multiply by a negative?
So yeah, the next one, if I just try to add down again.
You could add the top number. You could multiply the top number by -4.
Okay. I'm not going to have anything go away. Well, if I just add down right now, I won't. But you're right. If I went back and I either looked at the x's and said, hey, I want one to be +4 and one to be -4, I could multiply this top one by -4. That would work. Or some of you may look at y and say, well, wait a minute. Could I multiply this by -2? Because that'd be -4 and I could get rid of y. Either of those would work. And this is awesome in that it's being one of my last videos of the year that I can just feel the flexibility to be able to go people, people, people. Social, 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 phones, phones, phones. And then we wonder, wonder, wonder. I don't get it. I just don't. That is not a recipe for success at all. Oops, I should be using this color. Let's do that. Not a recipe for success. So again, make sure it's a -4. In this case, we're multiplying through by. You're like, now why am I doing that again? Because now, if I leave the bottom one alone, the x's cancel. And I add down. And again, I'm not subtracting 14, don't add it. But again, that's the y value. So to finish this one off, I'm going to kind of bubble this in for step 2 here. Again, pick either equation you want, and we're going to plug the y in. So I'm just going to use this bottom one. Either one would work. Substitute your y in. This is one of those spots, too, for some of you that may not have been doing homework stuff back then or the practice. That now you've got this. If you do the practice, it's going to serve you doubly well. Because not only is it going to be fresh in your mind for the final, but you're also going to be able to turn it in and get points. So, I mean, hey, double dub. So you can kind of see why the final itself probably isn't going to be incredibly long, because some of these problems got some steps to them. But that's all right, too. And again, anything you see here, we're going to end up having for you on video later, too, if you need to go back and check. So, one more elimination. You're like, Hardy, it's kind of like number 4, because 6 plus 3 don't cancel. -20 and -10 don't cancel either. It's true. So, I wish this were 6 and -6. They'd cancel. So what can I multiply 3 by to get to -6? still here. 3 times what would get me to negative 6? And we'll distribute that through. Leave the top one alone. Ooh, I see interesting stuff coming this time. 6 minus 6. Okay, those go away. Ooh. Negative 20 plus 20. Those go away. So there's 0 left on the left. 28 minus 42 is negative 14. Okay. Does 0 equal negative 14? Excuse me. Thank you. If the two sides would have been the same, let's say it would have been 0 equals 0, that'd be many solutions because they're basically the same equation. So again, I'm just kind of playing through here. They will not all take this long, I promise. Okay, how many solutions are there in the graph shown below? Well, let's see. You're like, wait, what is that? That is a black line in the black and a white line in the front. They are the one and the same. No solution occurs when the lines never cross. Okay, that didn't happen here. One solution occurs when at one point they cross each other. That's not occurring. Cannot be determined is just, that's never going to be the right answer. That's just silly. Infinitely many means it's the same line. That is definitely the same line. Now again, does that mean on the final it's going to be the same line? No. It could be one of those other things. Well, it's not going to be cannot be determined, but it could be one of the other ones. So just saying. Something to keep in mind. So when we get to this next part, given the following systems, identify which one has one solution, which one has no solution, and which one has many solutions. Okay, Hardy, how are we going to do this? At least at the start, we need to set these up like we were doing number 4 and number 5. So I look, and I'm like, crap, I can't add down and eliminate anything. So here, that's negative 8. I'd love for this to be positive 8. So it's going to be 4. I do not have room this time to do it to the side, so I will do this. I'm going to recopy my first one. And now I'm going to distribute my positive 4. Whoops, that's minus. Through here. Here's the good news with these problems. I get to this point, and I'm like, oh gosh, I'm going to have to do more. What the heck? No, you don't. You're like, what do you mean? Like, the problem's not done. This problem, since I actually got a y value, is going to have one solution. I don't care in this case what the x value is. I just know that there's one answer. That's all I care. So now, that part's done. Why? Because did it ask me to solve? No. It said, identify which one has one solution, which one has none. There's going to be no x's or y's left. Or many. But if y equals 1, it's going to match up with one x value, right? So you're only going to get one answer. I could solve the rest, but it's not going to get me any further. So I play the game again on the next one, and I go, okay, I'd love for that to be positive 12. 3. So I do the 3. I do the thing. And I keep the bottom one the same. Whoosh. Nothing there. Oh, whoosh. Nothing there. Okay. Negative 27 plus 21 is negative 6. That's correct. False. That's going to be no solution because the two sides. Now, if I'm really feeling confident that I got the first two right, I just put many solutions for the last one and I go on. But I'm not quite that confident. So I'm going to make sure. I'd really like this to be positive 6 so it went away. So we got to multiply by 2. We're going to leave the top one alone. Bottom one. And I start looking, I go, ooh, okay, those cancel, that's good. Those cancel, okay, that's looking good. Negative 18 plus 18 is 0. That's true. And so I could actually prove that it's many. Now, am I going to have you on the final do all three? I don't know. I might only put one question and say, okay, which one is it? Why is? But maybe. Just saying. Just saying. So again, that kind of took us through the rest of unit number 6. So it looks like this is where we get to leave unit 6 in the rear view mirror. So let's see here. Radicals. Hey, radicals. Oh, Hardy, you were lying. We're not going in the same order. This is unit 9. Okay, well, this is what it is. So this is 9.1 to what? 9.3? For those of you keeping score at a later time. So let me get a little help from my Unit 9 notes here. Kind of remind me of stuff. Oh, yeah. This is where my multiplication chart might come in handy too. Maybe. We'll see. I need this number to be broken down with a perfect square. Now, hey, I've got my multiplication chart here. So I'm looking through for perfect squares, and I'm like, ooh, that's perfect square. Let me keep going, though. Find the biggest one. And hey, I've even got the match in here. I don't even have to mess with the calculator. So 16 and 3. But the square root of 16. What is the square root of 16? Do I know? 4. Let me get out of, get out of there. There we go. I can always do it on the calculator. The square root of 16 is 4. So this is 4 times the square root of 3. Oh, I've got a class of... What's that? So, yeah, this is... And so the only difference as I go to add is I'm going to do what I did here for both of these. But hopefully I'm going to be able to add them up at the end. So let's see here. So 63 is still on my chart. So let me pull my chart up. We are. Where's my biggest perfect square in my 63 box? 9. So we got 9 and 7. Now, Hardy, 175 is not on my chart, so what the heck? Okay. Calculator, using these, I need to find the biggest one. Well, let's see what happens. Oh, decimals. No, can't do decimals here. So we're going to start, we're going to start dividing our perfect squares into 175 until we find one that goes in nice. Now, if you don't want to be like me and try every single one, you can maybe figure out which one's going to cut. Oh, there it is. 25 and 7. What's square root of 25? So I break down the 25, and now it's the same radical. If these radicals were different, you'd have to leave it. You'd be done, but they're the same, so they're like terms. So I can add up the outsides, leave the inside alone. Not always. Sometimes they may be different, and then I just got to leave them alone. Okay, let's see. We got to score. You're close. So I got 5 squared, and I got the square root of 3 squared. What's 5 squared?
9.
Careful. Squared and square root are enemies. They cancel each other. And just leave me the number below, and then we got to multiply. And to be honest, here comes the mind-blowing moment. Hardy, could I just put this in the calculator like if I did... Uh-oh. Not if you did what I just did. You can't. All right, let's try that again. Is it going to let me get away with this? I don't think it is. There we go. Oh, okay. So we can get away with the calculator if we think of it. Final exam, if you want partial points if you screw something up, yeah. But if you can figure out playing the calculator and you feel good and it doesn't turn out as a decimal, you can. Because some of you are like, well, I'm going to pull that trick here then. So watch this, Hardy. Ha-ha. And you're like, all right, 5 square root of 3 and times, what do we got there? 2 square root of 7. Oh, dear. Oh, dear. Oh, it's a decimal. Okay, can't do that. Multiply the numbers on the outside. Multiply the numbers on the inside. Can we break down the 21? Let's see. So 16, 9, or 4? 16, no. 9, no. 4, nope. As far as we're going. Yeah, sometimes we do. Why not? Let's see. Pythagorean theorem. Now I'm trying to think of the specifics. Oh, that's right. We just worked that into what we were doing. Pythagorean theorem. A squared plus b squared equals c squared. You're like, okay, Hardy, how do I know what the c squared is? The c squared is opposite of your right angle. So whenever you're trying to figure this out, that's where you find c. The other two sides are interchangeable. So this could be A, this could be B, that could be A, this could be A, that could be B. It doesn't matter. And so all I'm going to do is plug them into the equation. So A squared plus... Yep. Because mathematically, that is the only way to make sure we are accurate over here. So here's the good news, though. It says round to the nearest tenth if necessary. So we can get decimals, and we're not going to be mad about it. But we may not. I don't know. 425 is not the answer. Because I got to get rid of the squared still. Round to the nearest tenth. Okay. I'll let you use the calculator. I'm definitely not doing that in my head. Yeah, I got my square root in there. Now, this time a little different. So here, I look and I'm like, okay, now this time the a squared isn't on a side by itself already like the c squared was. So before I can do my square root, a squared's got to be hanging out on its own. This time I have the c value. That's why I label all my stuff in advance, so I can put everything in the right places when I'm plugging it into the formula. Well, this one I had a and b. A squared plus b squared. C was the mystery side. No, that's the mystery value. That's what we're trying to find. Because now I can find my A. Because your C is always going to be the biggest side. So if you ever get a value and your C is not the biggest side, something went wrong with the math somewhere. What's that? Pretty darn close. Pretty darn close to the final. It is. Oh, I think we can get a couple more in here. Let's try and get a couple more here. All right. Let's see. Can we knock this out? We'll see. Simplify completely. No negative exponents. Okay, reminders. Big numbers do not play by little number rules. 24 divided by 8 is still 3. Why did you put it on top of the fraction, Hardy? Because 24 is bigger than 8 is. What do you do with the exponents when we're dividing? Subtract them. 7 minus 3 is 4. The bigger exponent's on top. Now for the next one, we're still going to subtract. We're still going to do bigger. Oh, go ahead. I'm sorry. Right here. I'm subtracting exponents on my x's.
But there's 24.
Big numbers do not play by the little number rules. 24 divided by 8 is 3. And then my y's, 4 minus 1 is 3. The bigger exponent's on the bottom. I'm done. Here, leave the big number alone. That's the only one. But, oh, what do we do with negative exponents? Flip that bugger down to the bottom. It becomes positive. B to the fourth, it's not negative. Leave it alone. Those aren't the same variable. I'm done. We're almost there. We're going to get through this page. This is great. Big numbers, play by the normal rules. 6 times 4 is 24. Now what do we do to the exponents? Add them up. I can answer that question. Why is this so easy right now? Because you hear me speaking through it and we're going step by step. If we practice and back it up, then it does stick. Otherwise, when you leave that door, it goes right back out the ears. Once you take the earbud out, it goes right out. It just goes away. I'm just saying. What's 3 to the second power? 9. Power to power, what are we doing to the exponents? Nope. Multiplying. 2 times 2 is 4. 3 times 2 is 6. Keep it simple. Last one for today. Abe was simplifying this, but he did some stuff wrong. Circle the line where he made a mistake. Okay, let's see what happened here. Abe, what are you doing? Simplify here. So that would be x squared. Oh, Abe. What do we do with negative exponents? So since it's on the bottom already, we flip it to the top. So let's see here. X squared y cubed y to the 5th. Oh, there's no denominator anymore. Okay. You're like, Hardy, those don't look the same. Well, let's go a little further. What do I do to the exponents now that I'm multiplying these y's because they're together? We're going to add them. Now let's, uh-oh. Uh-oh. What did poor Abe do? Yeah. Yeah. Abe. Subtracted instead of adding exponents. Oh, Abe. Oh, Abe. Okay, so we're basically through the first half here. We'll keep chatting through the second half tomorrow. And yeah, especially since you're circling the step that it is, I'll be able to tell.